Good morning. I am the chairman of STEP, Science and Technology Education Partnership. Welcome to our VIP tour today, where we go behind the scenes with the tokamak D3D here in San Diego, General Atomics. And we're, of course, the guest of Rick Lee and Alex Nagy, our tremendous partners for 20 years here at STEP, our science show. And this tokamak is absolutely amazing. It's the largest fusion research facility in the United States, and they're doing cutting-edge research into the future's clean source of energy because it only produces helium as its byproduct. There is a lot of interest in this for the future to reduce our carbon footprint and also to improve on global warming. So it's wonderful to be here to show you a behind the scenes at the tokamak D3D research facility here at General Atomics. And here we see some of the plumbing that's involved in this. Water that's cooling it down. The temperatures get to, what, 10,000 degrees?
100 million degrees inside in the plasma.
So the temperatures get to 100 million degrees inside the plasma. Of course, when you think about it, the static electric spark is 10,000 degrees, but it's just for a split nanosecond, so we don't really feel it. But even a spark, which creates plasma, is 10,000 degrees. So this is 100 million degrees, a factor of 1,000 times hotter. So this is really unique to be inside of the largest fusion research facility in the entire United States for this behind-the-scenes tour. We're very thankful to Rick and Alex for their hospitality today, and all of the General Atomics team here in San Diego. Of course, a lot of this is sensors and sophisticated electronics to keep track of what's happening inside of the tokamak reactor chamber. And now we're going to take a look at a cutaway of what's inside of this machine. That's a whole bunch of electronics, magnets, and of course inside is the plasma that we're working to drive through a magnetic pinch to create fusion, a future source of energy for the entire world. This is the full-size cutaway of the D3D tokamak reactor research instrument. And this shows the huge electromagnets on the outside. This is the main electromagnet right here, and then these are internal electromagnets, and the fields are going crossways. So one electromagnet set goes this way on the magnetic field, and another one goes this way. And altogether, these fields cause a compaction of the plasma inside of the chamber, compacting it at a very high temperature, 100 million degrees, to create the fusion. And this fusion process now lasts for 5 seconds. Each shot is 5 seconds. We saw on the screen inside that they have done 185,000 of these shots. They try to do probably like 20 or 30 per day. In the past, these shots lasted only milliseconds, but over time we've got more and more capable of doing longer shots. And one of the things that the General Atomics tokamak D3D is known for is all the diagnostics of what's happening inside of this chamber. And that requires a lot of sensors to determine the temperatures, the wavelength of the field, the plasma inside, and how it's reacting. And in fact, General Atomics invites researchers from around the world to come to study and use this D3D tokamak. So it's one of the unique properties of or facets of this research facility is it's really international, although it's called the National Fusion Research Facility, and it's the largest magnetic field plasma research center in the entire United States. So this the fusion inside is, of course, extremely hot, 100 million degrees. These are replicas of graphite plates, of course, a form of carbon that is able to withstand very high temperatures and it protects the rest of the structure, the magnets and the containment facility to allow this fusion reaction to go on at these very high temperatures.